every time. Okay, so we're going to start out with a standard part, and our objective today is to bring a spreadsheet in with all of our dimensions to create our Ipart from. So I'm going to start with the standard part. And I really don't have anything in this part yet, but you know how we start out in the sketch? Finish that sketch, and you can come back and edit that sketch later to make your sketches for your extrusions. So we're going to go straight to Manage, and we're going to create this as an Ipart. Now, inside of here, there are a lot of things that we want, but there's another way to open this. So we had to create this, and then we're going to get out of this. So now that we've created the Ipart, did it even give us one? Create Ipart. I guess we have to insert one more part. So now we have two parts at least to make an Ipart. And so if we right click on this, we can edit the table or edit it via a spreadsheet. This spreadsheet uses a .xls extension, which is 1997 to 2003. I'm asking someone to help me with this. I remember it. But do you notice how this has an actual formulated way of looking at these? This is why we can't just start off with our own table. So we have to have a formulated way that it's going to look at this. So we have a part number and we have a member name here. So what we're going to do is we're going to bring up this start part, and I don't remember, I think we imported this, but I'm going to see if we can copy it in. So what I'm going to do is I'm going to grab this whole thing from the very first, just select that whole thing and right click and copy it. Now what I've done was I went in and I put in all these differences. Some of these, like these rows, this right here is a feature. This is a feature, this is a feature, whether it's computed or suppressed. These are all of our features, and the rest are dimensions, because anytime that they have an underscore, they're going to be a parameter, and these are dimensions that we're looking for. So I'm going to copy this entire thing, and I think I'm going to grab just this part, Control C, and I'm going to go back to Inventor, and I'm going to pull this table up. I think I already have it up over here, and I'm going to paste it in here. So if I grab this in, and now it brought in the actual parameters and everything for our parts. Now we can go in and add these as we want, and now we can add them to the spreadsheet. So I have these in my part now, and it says I want to save every time for it to incorporate these changes into my part. We don't have anything in the part, so it's not going to make changes. You see this empty cells found. Okay, so I started this thing in here. Notice that it pulled in all my part names immediately. Let's go back into the table and look at it. It pulled in all these parameters, but we don't have any parameters in the part yet. So it's saying that all these are empty. So if I filled in all these dimensions and I went back and I named my features, this would build my parts. So if I wanted to cancel this and I go into my part, go into the table and right click and edit via spreadsheet again. Now I have two spreadsheets. I have one that I put all my data in, and we were saying, well, this just seems like just a waste of time, right? So we didn't want to use that, so what we did was we pulled in our student Ipart sheet, and I had one that I saved over here in my U drive under 2402, and it actually has all the dimensions and everything in here. Now this one, we notice that the ones don't want to make. We notice that the ones want to be copied. It wants to have some other number. But what I'm going to do is I'm going to copy all this right now. And I need to copy. Okay, I'm going to copy this, and I'm going to paste it into this other spreadsheet. Can I do this like this? Huh? Control V, just Control V. Okay. So it put everything in there like I want it. So I'm going to go ahead and close it and save it. And go back into Inventor. And I want to see what it has in here now. So let's just double click on the table and look at the table in its current state. No, I wanted to save my Excel spreadsheet.
Did you paste it into the Ipart or to this one?
I think I pasted it into the wrong one. Doggone it. So let me try it again. I'm going to bring this one in, and I'm going to copy it, and then I'm going to put it in there. Let me see. I got to go from diameter here, from all these formulas that I put in, down to here. Control C, and I'm going to get out of this so I don't get confused. And now I'm going to go over here, and I'm going to edit this via spreadsheet. And I want to continue because it's empty. I'm going to go to where it starts and Control V and let it paste everything in there. Now I'm going to save this and get out of it, and I want to see what it does. Okay, well, it can't do a lot because we don't have any sketches or anything, right? So let's go into the table format, and we can see that it's taken all of our parameters and all of our numbers and put them all in here. So now we're starting kind of from the data. Now we're going to go back and we're going to start drawing our geometry and naming it exactly what's in here. So I'm going to start with the sketch right here. And I'm going to start with this sketch. It's nice to have that other spreadsheet because now I can start drawing these things in. But what I'm going to do is I'm going to put in a circle. And I need to know the diameter of that. So I'm going to say equals diameter. Sorry, it was DIA equals. DIA equals 0.063. That was the diameter of the first part. And so that is now my parameter that matches on the spreadsheet. And now I'm going to extrude that. Do you guys remember the length of that piece? 187 or something. Let me go and look at my spreadsheet. So I'm going to go over here to this spreadsheet that I have my data in. You still need this spreadsheet a little bit. So it's 063 and 0.24 long. So I'm going to keep this over here just to help me. So my length, LEN, equal 0.24. Okay, so now that we have the length and the diameter actually created in this part, let's go through our parts.
I think you had the rod big end selected.
Mm-hmm.
You did that definition, so that you might have had the first part selected.
That looks good. That looks good. The first sketch is just giving me those two parameters. So I'm going to go down through here, and you notice how the diameters and the length are changing. Right? So I'm going to go to the first one that has the first feature that we're going to suppress. And if I bring this over, I would make the first flange, and then I put in those numbers. Once I put that in there and name that feature flange, and the two parameters for that, flange diameter and flange thickness, it's going to make every one of the flanges for us. Does that make sense? So then we'll just start going through these features. So on this one, I'm going to select this to make a sketch on. My diameter is going to be my parameter, flange underscore. We have to have an underscore, no spaces. DIA equal, and that's going to start out with, let's see, we're starting on the second one, so that's 0.187. This second part is the first one that has a flange. Okay, so that's 0.187. And then I'm going to extrude that, and we said that we wanted our pin length to be the entire length. So we're going to extrude this into the part. So I'm going to flip this way, and then this is going to be the flange thickness equals, and then I have to give it a flange thickness of 0.025 and say OK. So now I'm going to save this as, let's say, I start part, because that's what we named the spreadsheet. Okay, so let's go to the next one and the next one. All those were the same size though, right? What about the valve tappet? That had a different size, different diameter, different length. Valve tappet bushing. That's right, but we haven't gotten to that feature yet. The question was a revolve. They have features missing. So as we go across the spreadsheet, this is a whole new way of thinking. So I'll just put in the flange right here. Now I'm going to put in the neck. Then I'm going to put in the chamfer, concentric hole dimension, concentric hole, revolved hole, and then that 45 perpendicular hole and the 45-degree flat. So then we would go to the next one. What's different in the next parts? Well, one of them has a neck, and that starts right here in these roller pins. But I better be naming some of these, shouldn't I? This one is the pin. This one is called flange. Okay, so some of these don't have a flange. So therefore, we need that to be suppressed, and that's coming from our spreadsheet. I have not seen a problem though with my ones yet, which is really working out good. Okay, when we put a 1 in this spreadsheet, we don't have to, if it's suppressed, we don't have to have a number in there. I'm sorry, I said that wrong. We need a number in there, but it can be like a 1. It doesn't have to be a size because it's not being computed in that space. So what we're going to do now is we're going to put this neck on here. So I'm going to go down to this one, and I'm going to have to name this, and I'm going to put in, there are no different size necks, and what I'm calling that is that C-clip area here. So I'm going to select this solid body, this origin, this plane, create a sketch on it. I can hit the slice graphics, but I'm going to project geometry of, if you select all 3 of those planes, you're bound to not miss one. Okay, I'm also going to project geometry at the end of this because we put in that 30 dimension, 30 thousandths on here, so because the length of the pin might change. I also want to project the geometry of the side of this part. I'm going to put it in a rectangular cut. We know that this is 30 thousandths, and that is the same in all these pins. The flange diameter, when we need a diameter, we're going to select this axis and we're going to make it a center line. Now we can put a diametric dimension in here, and that can be 0.073. Is that correct? Flange diameter of the neck. What is that number? Do you guys have that from your drawing? I'm going to put it 0.073 and we'll see. And I know this is 18 thousandths. I have that much memory, but not very much more. Does that look right? Does anybody have your PDF that I gave you? Oh, you can't do anything because I have you locked down because I am the control queen. I'm so sorry. Is that correct? Okay, thank you so much, Justin. So what we're going to do is we're going to revolve that cut, and making it a cut, it wants us to provide an axis for it. So axis is, what happens when I can't pick my axis? It already got my axis. You see that? So it's already showing it. All right, so then we have the neck. So we have to name this neck. Same format in the typeface, meaning all caps are uppercase and lowercase. Same spelling, underscores, everything. Very good. So now when I go back to this one, I have one in that one, It stays 30 thousandths from the end, this one, and this one. Does the valve keeper pin have one? No. So it is being suppressed now. Now the next thing that I would do is go in and put in that chamfer. That is on the roller pin. I put the chamfer in. And that's 15 thousandths. Okay, so chamfer wants to be computed or not. So we don't have to change the dimension, but we're going to name this chamfer, all caps, because that's the way it is in the spreadsheet. Okay, the next thing we would do is put in a concentric hole. Which part has a concentric hole? It's probably the cam bushing. It's the first one. So if we make a hole in here, and it's a concentric hole, I'm going to select that to be the case. Select on this plane, and this will be my concentric reference. But let's make this hole a bit smaller, which is 0.1562. And this is my concentric reference, would be this surface. And I'll say, okay. Now I'm going to name this hole concentric hole, and I think I have to go back and edit the diameter of that hole because we're going to have multiple size concentric holes. Now this one doesn't have an underscore because it is a feature, not a parameter. Parameters are the only ones that have to have that. Okay, so I'm going to go back into this feature, and I'm going to say, do you see how they'd be different too? We can't have them have the same name as a feature or a dimension. That's how it knows it's different. So we'll say okay. Okay, so let's go into the valve tappet. Does it have a concentric hole? No, it has that thing on the bottom. It has that revolved hole on the bottom. What about the bushing? It has a concentric hole and a different size. It's all coming in correct now. Tail shaft retainer. That's the one with the countersink. So we're just going to go in to those features that have those next features that we've listed on our spreadsheet, put them in, name them, name their dimension value if you want to, and then all your parts will be created. Does this seem easier than going through the whole thing and doing this piece by piece? I could probably finish this in an hour or less with the spreadsheet. But it's nice to have that spreadsheet. We had to gather the data in the spreadsheet to be able to upload it. And we put it in the order that we wanted it. So that's what's nice about the spreadsheet. Thank you and good night.